Hello everyone. Hello everyone. It's me, Dr. Savitha M. In continuation with my discussion on environment pollution and water chemistry of engineering chemistry VTU syllabus, I am now discussing on the ion exchange process in this video. Okay. All the previous videos I have I have uploaded in the channel My Intuition. Kindly share the video, like and subscribe. In this video session, I shall be discussing on softening of water in by ion exchange process, desalination by reverse osmosis. Let us first speak about or discuss about the softening of water by ion exchange process. Let's first understand what ion exchange process is. Let us assume here there's a chamber and it has the certain what resins. R represents the resin which is having a replaceable X minus. It can also be a plus also, positive ion or negative ion. These are all replaceable ions. X, what is indicated as X. Okay. Now you add water which is containing maybe X minus ions. Okay. It can also be positive ions or cations. For understanding, I have just considered a negative ion, anion. Okay. Now the water is containing an anion. Now when you pass water through this chamber, what happens is, see the resin Rx exchanges the X minus ions by Y minus ion. This anion is exchanged by the another anion which is coming from the water. Okay, see. Now, when it is getting exchanged, the X minus is again taken out, right? Because it is not there in the along associated with the resin now. So similarly, if all water when it passes, similarly when all the anions be replaced by Y minus, the entire resin will now we have only Ry minus. Therefore, the water which is coming out will be rich in X minus. Okay, this is the ion exchange process. Now, this process takes place until all the X gets replaced by Y. Once the resin completely gets replaced by Y, this is now not possible for next set of reactions because there is no X minus to get exchanged with Y. In such a case, you need to regenerate. You need to make the resin ready for next reaction. That means you have to again regenerate the resin. Now this regeneration means you again add the solution which contains X minus. See, the solution has X minus ions. Okay, you add that solution. That time the Y will be replaced by X again. Now the resin is ready for use. Okay, this is regeneration process. That means you get back the resin. Okay, this concept is used in softening of water by ion exchange process. Now the hard water, the water which has to be uh, treated, will contain soluble salts of calcium and magnesium, right? Like bicarbonates, chlorides, sulfates, all are anions, and positive ions, metal ions, are calcium and magnesium, right? Sometimes the water may also contain cations like sodium, potassium, etc., right? We have understood that hard water cannot be used for industrial and even domestic work because it has ions. In industries, it will cause corrosion. We have discussed in detail about that. Now, hard water, if it has to be used, it has to be softened. Okay. Now, how softening can be done? Softening can be done when all the this negative ions, anions, and all the positive ions, cations, will be replaced by uh, H plus ions and OH minus. Okay, so this process can be done by cation exchanger and anion exchanger. Okay, so this process will be explained in ion exchange process. Okay, this is a schematic representation of an ion exchange process. See, there is a cation exchange bed and an anion exchange bed, right? Let me explain uh, individually. Now cation exchange bed. Now here this I mean chamber contains the resin which has replaceable H plus ions. Now you inlet the water which is hard water. Hard water means it will contain calcium ions and magnesium ions are cations. The sulfate or chloride ions are as anions. Now first the water is passed through cation exchange bed. Okay. Now in the cation exchange bed, see the resin is having H plus ion. The water which is coming, the inlet water has calcium and magnesium ions. So when it passes through the exchange bed, all the calcium will be trapped and H plus will be released. Okay, so the water which is coming out from the cation exchange chamber will be rich in H plus ions. That means it will be acidic in nature. Now, with the help of a pump, this water is fed into the next chamber. The next chamber is anion exchange chamber. In the anion exchange chamber, the resin has hydroxyl ions, replaceable hydroxyl ion. All these exchange bed is being designed such that it has hydroxyl ions. Okay. Now the water which is coming from the anion exchange chamber, cation exchange chamber, does not have any cations. Okay, but it is acidic because all the cations has been trapped in that place. H plus has been released. Now the water also contains anions because anions are not removed in the cation exchange chamber. Water will contain anions. Now when you pass through the anion exchange bed, what happens is the anions get go and sit in the place of hydroxyl ion and it will be exchanged. Therefore the water which is coming out from the anion exchange chamber does not contain any uh, anions, that is chlorides or sulfates. Anions in the sense the hardness causing anions. Okay, so it will have OH minus ions. So from the anion exchange chamber there is H plus ions released. From the cation exchange chamber hydroxyl ions are released. They later combine to form water and demineralized water, that is neutral pH. The water comes out will not have any positive ions also, negative ions also, which is responsible for hardness. This process is called as softening of water because we have removed the hardening cation and anions, and this is done by ion exchange process. Okay. Now once when all the in the cation exchange bed, once when all the resin the replaceable hydrogen has been replaced by cations, that is calcium or magnesium, then once when all the sites are full by cations, you cannot use it again. You have to regenerate. How to regenerate? You have to pass you have to just disconnect the anion exchange chamber, and then for the anion exchange chamber you have to pass hydrochloric acid. When you pass hydrochloric acid, this calcium will be replaced by H plus ions of say chloride, HCl. Okay. Now water which comes out will be rich in the cation or anions which is released from the resins, but the resin is ready for use. Similarly, the anion exchange chamber also, after disconnecting, you have to pass sodium hydroxide. When you pass sodium hydroxide, the site which is already filled with the chloride or sulfate anions will be exchanged with hydroxyl ion, and the resin is now ready for use. Okay, so once you regenerate the cation exchange chamber and the anion exchange chamber separately, then you again connect it and it is again ready for use. This is the ion exchange process. The next process is desalination of water by reverse osmosis, right? Desalination means, you all know what desalination means. Desalination means it is a removal of salt from water. Sea water, if you remove the salt from sea water, it is again, it does not contain any salt, so it can be used. Okay. Desalination is one of the solution for the water crisis. There are certain countries which completely depend on desalination, where they do not have much fresh water availability, right? The principle of desalination is, for example, if a pure solvent like water and a solution like example sea water are separated by a semi permeable membrane, then the solvent flows through the membrane, diluting the solution in the process. Okay, and after a certain time, the pure water also becomes salty in nature, and this will take place until an equilibrium is reached, and then this phenomenon is called as osmosis, and the pressure developed is called as osmotic pressure. Okay, that means from pure water, I mean from salty water, salt water uh, will be pure water also will become salty in nature. Okay, now the reverse osmosis means the salt from the salty water has to be removed. Okay, that means what happens is, let us assume, see here there are two chambers. In one chamber salt water is taken, there is a semi permeable membrane. You need to apply external pressure which is higher than the osmotic pressure. In that case what happens is, the salt will remain in this chamber itself, whereas the water moves towards the pure water, the other chamber, right? So the level of pure water goes on increasing, because the water molecules are passing from these concentrated solution to the um, pure water side, that is dilute solution. Okay, so the level of the solution here decreases, and for this process and higher applied pressure is required, and that should be higher than the osmotic pressure. Okay, and this process is called as reverse osmosis, because it is going in the reverse of the osmosis process. Okay, this is called as reverse osmosis process. By reverse osmosis also water can be purified. Okay, so this all these videos I have uploaded in the other videos also I have uploaded in the my intuition channel. Kindly you all have, can refer, and also the notes also is uploaded in the description box. Any I mean you have any doubts, you can share through the comments. We will respond to it. Thank you.